Okay, here we go. I thought I'd try to stream again today, only because I'm not sure when the next chance I'm going to have to stream is. Let me just make sure my settings are good. I'm using a slightly different setup than I was before, so hopefully everything's looking okay. Um, what we finished last stream, so this is all about making a roguelike. I'm learning how to make a roguelike in Rust using this roguelike tutorial. I am attempting to use RLTK, which is what the roguelike tutorial is all about. It's this RLTK crate, and it in turn uses something called specs, which I still have yet to learn. So what we've gotten so far is we're worked our way through here. We got monsters working, and what they can do now, is chase after you using this, the code we entered last time. We'll search for, they say, valid exits. Basically, can you reach one tile from another tile? So if you're in a particular XY coordinate, particular XY coordinate based here, IDX is decomposed into an XY coordinate. Then we look to see if x minus 1 plus 1, y minus 1 plus 1, basically the four squares surrounding the point, are not walls. That's what this is checking here. Checking that they're not walls. And once we have that information, that gets fed into the A star search that comes with the roguelike toolkit, looking for the best path to the player. If there is a path to the player, and we're not standing on the player right now, then moves one's position closer to the player. And it uses the 2D distance to determine the shortest path to the player, which is it says Pythagoras. It's Pythagorean theorem, a squared plus b squared, root of that. That's what we got working last time, and now if I hit refresh, I can walk around and monster can see me, and then if I take a non-step, it'll try to follow me, and if I walk away, it currently gets stuck on corners because apparently it can't walk around this way. And I would have thought that the A star search would still find a path to the player, even if it's, direct instead of having to go diagonal. But I don't know if that's a bug in this code or a bug in the A star search or what, but there's definitely exits available for the monsters. For this particular monster, he's got 2 exits available, and if you follow that, you do get to the player. So I'm not sure why the monster got stuck on the corner. I'm not going to worry about it right now, but maybe we want to think about in the future how to fix that. Look to see if there's a bug somewhere that needs to be addressed. This was the code. I don't need that anymore. The other thing that happens is if the monster does get on top of you, notice how if I got close enough, suddenly the monster was able to move to me. So I don't know, is that this greater than 1 business? I don't know. But if the monster does eventually move on top of you, which he now is on top of me, actually underneath me, right? If I move, you can very slightly see an O there just before it disappears and moves underneath the player. So there's one frame of we're separate, and then in the very next frame, he's on me. So that's that. That's the blocking access. I mean, that's the monster, chasing the player section. What I meant to say is next we're doing work on blocking access. So we don't want, so that's where we are here. Oops, this is my old screen. There we go. This is where we were. Monsters can now follow you and chase you. And what we're going to do next is stopping them from walking on top of each other. So we don't want monsters to walk on top of each other, nor do we want them stuck in traffic. Stuck in a traffic jam, hoping to find the player. We'd rather that they are willing to try and flank the player. We'll accompany this by keeping track of what parts of the map are blocked. So we're going to add something to the map called blocked. Okay. No, map. So we have all of these, and it's another Boolean vector. And we'll initialize it. Where do we create a map? Here. Okay, and then we're going to populate it. So let's introduce a new function to populate whether or not a tile is blocked. And this is in the map impl. Pub function populate blocked. Icon of tile and self tiles itermute enumerate. So we're iterating over the tiles mutably, so we can change whether or not the tile is a wall. Self blocked equals star tile equals tile type : wall. So if the tile is a wall, then blocked is true. And then we're going to change is exit valid to use that. Okay. If it's not blocked, then the exit valid. All right. So it doesn't say how that's going to help. Keeping track of what parts of the map are blocked. We already know. So blocked is basically just a copy of tiles, right? Or it's a reduced version of what tiles are. It doesn't say the tile type, but it says whether or not it's a wall. Okay. Then to components, we add whether or not it blocks the tile. So pub struct blocks tile. And we register that. Oops. Blocks tile. And then we want to apply it to NPCs. So when we create monsters, down here, right here, when we create monsters, we have a position, a renderable, a view shed. We have the fact that it's a monster, we have a name, and now we're going to add with blocks tile. Right? And then we need to populate the block list. So in the map indexing system, so this is something brand new. This is a brand new system we're creating called a map indexing system. Okay. Specs prelude. Super. We're going to have map, position, and blocks tile. Pub struct map indexing system, which is empty, and we create an implementation of system for map indexing system. Our system data is write expect tick a map, read storage tick a position, and read storage tick a blocks tile, like that. Then we have a run function, like the self and data, which is also a self system data. Let mute map position blockers equals data map.populate blocked. So that's the new source lib map, right? That's what we just wrote, was the populate blocked function, which just loops over all the tiles in the map and says whether or not it's a wall. And then for each position that has a block, but we don't care about the block itself, going to compute the index. And we're going to set the blocked value to true. So this code here sets blocked to true if the location has a wall. And this code here will add to that block list if the position contains something which blocks some entity which has a component that blocks movement. All right, so this tells the map to set up blocking from the terrain and then iterates over all the entities with a blocks tile component, right, and applies them to the blocks list. We need to register it with run systems, okay? It says in main, but I moved it to, why can't I save this? There. I moved it to something called game state, right? Because I didn't want to keep it in main. But down here we have run systems, the visibility system, the AI system, and now we're going to add map indexing system, map index dot run now, self ECS, and then the maintain. All right, and then we have to add it here. No, we got everything from the crate. So this should build, and it doesn't. Oh, line 48 needs a semicolon. But, oh, because I need to add map indexing system to my library module, right? To IP, there we go. Map indexing system. Boom. Ah, that's even worse. Oh, I put is. There we go. There we go. Okay, so now if I refresh, the monster will chase after me but not move on top of me. Oh. Oh. Okay, that didn't work. Why not? If I do this, yeah, he still moves on top of me. So what did I do wrong? We're definitely adding blocks tile to the monster. And we're definitely calling the map indexing system, which finds all the monsters that have that. Lib. And inside map, we're returning whether or not it's blocked instead of whether or not it has a wall. Do I... miss? And we definitely do it after the monster AI. Oh, monsters no longer end up on top of each other, but they do end on top of the player. Okay, because we didn't add the player to the list of things that don't block the monster. So let me see if I can find another monster here. And because there's a monster under me, that one shouldn't. Try to. Oh, look at that. Now I'm on top of the. Alright, he's not trying to get on top of me now. But I can move on top of him. Something's still a little janky though. I can't quite put my finger on it yet. Something just doesn't seem quite right. Because the ogre, like if I go right here, the goblin tries to get closer to me, right? And now if I go down, he's not moving. I'm confused by that. Did we miss a clear or something? Do we have to clear out the populate block? Should populate block have a clear everything at the front of it? No? Something is off. We can make the monster only yell when it's adjacent to the player. So we can do that. Source lid monster. Kind of ignoring the other issue for now. So in here we can say let distance is equal to RLTK. Hence alg Pythagoras distance 2D. Point new pos.x pos.y. Our player pos. That's the only thing in there. Yep. And then if distance is less than 1.5, we'll shout the insult return. Otherwise, we'll try to get closer. Okay. Oh, and then we want to stop the player from walking over monsters. In player RS, we replace look for walls to look for blocked. Okay. So in player RS, we have a wall here. So instead of walls, we just say if map blocked, dest. Oh, if not map blocked dest. Okay. So let's try that. Refresh. Okay, now I can't move on top of the monster, and the monster can't move on top of me. Oh, but now I can't go past the monster there. So the only way out is that way. That's interesting. The orc becomes a permanent obstacle that cannot be gotten around because there's blocking. Okay, that makes sense. Since we already put walls on block list, take care of the issue. Block perfect. Oh, yep. So they block perfectly. So the monster that wants to be in your way is an unstoppable obstacle. Okay. So what do we got? Git status. We've got this new indexing system and then a bunch of different changes. Git diff. Staged. There we go. So we added a blocks tile and we run our new map indexing system. Map indexing system fills in this new blocked vector. Populate block looks for walls. Vector starts out as all false. When does it get cleared? Because it must get cleared because I'm able to walk where a monster used to be. Right? I can walk through this corridor and orc walk through the entire corridor. So it must be the case that something's setting it to false. Oh! Yeah, okay, I know it's setting it to false. I'm being dumb. This is setting it to true or false based on the map. And then we just add the new monster locations there. Oh, we got an extra new line in that. Let's clean that up. Okay. And then we only shout insults if we're less than 1.5 squares from the player. We check the player position. Sorry, we check the block thing to determine whether or not to update the player position. And then monsters block tiles. Okay. That was pretty straightforward. Oh, we want a cargo format and Clippy it. Everything good? Oh, we got a couple of things wrong here. This got sorted. This got rearranged. We got the space put in the right spot. I wonder what Clippy's line length limit is. I mean, I've got my terminal here set to 80 columns, but Clippy obviously prefers longer, and then it needs the space there. Okay, git add source, git commit. What do we got? Players and monsters cannot step on one another. Right? Good. And the other thing I wanted to do was to, I think I can do that here. Just put this up on GitHub. So let's create it, sign in. I will sign in on my other screen. Let me do that on my other screen here. Sorry for the temporary radio silence while I get my password into GitHub. Oh, when I do that, apologies for this. So I can just use that password. No. Oh, I'm logging into the wrong thing here. That's dumb. Copy paste. Password managers are good. Alright, so I'm going to create a new repo. I'm logged in, so I should be able to just pull that up here, right? .com. Yep, I'm logged in. Okay, so I'll create a new repo, and I'll call this RLTK tutorial. All right, so we have a repo here. Let's let me see what I can do regarding. No, not that, and not that. That, okay. All I'm trying to do is push this to this repo. Let me grab this. And I can set this as the origin. Oh, come on. There. Copy. Alright, so git remote at origin, right? GitHub colon that. I've got a config file to set that. And then git push -u. I'm going to force. There. So now it should be all here with 30 commits. Excellent. So that's right there. So I'll just have to remember to keep pushing it after every change. Let's see. I've been going for 25 minutes. Let's see if we can diagonal movement. Yeah, we can do this. This should be straightforward. All right. So it'd be nice to be able to bypass the monsters, and diagonal movement is a mainstay of roguelikes. Excuse me. So let's go ahead and support that. Okay. The map. And we're going to just add to the valid exits. Of course, what we have here is just these 4, so we'll have to add the other 4 directions, right? And it'll be x minus 1 y, minus 1, x plus 1 y minus 1, then x minus 1 y plus 1, right, x plus 1 minus 1, x plus 1 y minus 1. So these, oh, I see what they're doing. Okay, so let's do that, the same thing. X minus 1 here, x plus 1 here, and these two are plus 1s, right? And then 1.45 for the distance. And then instead of idx plus w, it's idx plus w or minus x idx minus w minus 1, idx minus plus 1 minus 1 is idx minus w plus 1, idx plus w minus 1, idx plus w plus 1. This is super easy to read, right? And there's no way you could make mistakes anywhere along here. 2 minuses, a plus minus, a minus plus, and a plus plus. And then for idx, it's minus minus, minus plus, plus minus, and plus plus. Okay, that looks good. And then diagonals for the player. So source lib, that's all in the player, right? Yeah. Left, right, up, down. And then we're going to add these. So we're going to have numpad 9 or y is try move player 1 minus 1 ECS. And it's going to be 7, 3, and 1, and y, u, n, and b. And then these are both plus 1s. That's a minus. That's a plus 1. That's a minus 1. All right. And now I can diagonally dodge around monsters. Okay, let's see if this compiles. Nope. 36. Those should all be commas. Good. Okay, now let's see if I can move diagonally. So I don't have a numpad, but I do have a Y, U. Oh, that's backwards. B and N. B and N are correct, but Y and U are backwards. Okay. So Y should be X minus 1. Yeah, that makes sense. X minus 1, Y minus 1, and U should be X plus 1, Y minus 1. Did I get that backwards here, or is that backwards in the tutorial? Y should be X plus 1. Yeah, that's backwards. Okay. Oh, but numpad 9... Okay, that's what's backwards. That's what's backwards. So let's leave this in the same order. Oops. Minus, but we're going to flip around these guys. Because 9 is the direction for up and right. Up and to the right. I don't have a numpad, like I said, so I can't test those, but I'm going to just make a huge assumption that that's working. Okay, Y and U are correct. B and N are correct. Nice. So can monsters also move diagonally? They can. But they still get stuck on the edge of the walls, and they shouldn't. I'm going to have to look into that. Alright, so cargo format, cargo clippy. Are we all good there? Get diff. Not much change, we just added those additional diagonals and added the ability to use them for the player. Alright, I think that's good. Git add source, git commit diagonal movement, and push that up to GitHub. Refresh. Oh, let's take a look at the commits. Oh, she blows. All right. So we're going to leave it there. Thanks very much for watching, and I hope to catch you on Monday. Take care.